Look at a new way of solving a system of equations. So previously, you solved an equation or a system of equations by graphing them using Desmos. So you would graph each of your two lines, and where those two lines crisscrossed, that was your system of equations. That was your solution. And we even did this for parabolas. So you had a line crisscrossing a parabola and recognized that the solution was where those two lines intersected. Now, because there were more than one solution. Today, we're going to be solving it in a different format. And the reason why we're doing so is because there are three variables. If you remember, this is just x and y, which it means it's in a 2D space. That means it's in a flat two-dimensional space. This one's going to have three variables, which means we need to have a three-dimensional space. And so the solution for a three-dimensional space is always going to be a line. But how would I ask you to graph it in a three-dimensional space? We don't really have a means of doing that. And so there is elimination, which we can do, but the standard for analytical algebra 2 doesn't say solve it with elimination or substitution. It says solve it using a matrix. So that's what we're going to be doing today, is solving systems of equations with three variables using a matrix. So the first thing is you have to be able to set up a matrix. So what is a matrix? Well, it's a set of arrays. It is a set of numbers put in order where you understand that each one represents a piece of data. And so if I were to, the way to write a matrix is to draw a bracket. And in fact, there are going to be two, and well, really, in reality, there are three matrices here, but we're only going to worry about two of them right now. And then once we get to the solving, I'll explain where the third one comes from. So if I were to put a bracket around these, you should see very quickly where these numbers are going to come from. And so we're going to name it based on its rows and its columns. And it's always going to be rows first and then columns. So this is how many rows? Well, there are 3 rows by 3 columns. 1, 2, 3. So this one is a 3 by 3. This is a 3 by 1. Because there's 1 column. So in our 3 by 3, we're going to have 3 rows and 3 columns. And we just simply use the coefficient in front of the number. So this becomes -5. What is the number in front of this y? Well, it's 1. What's the coefficient in front of the z? It is -4. 2, 4, and 3, 6. This 3 is a -3. Make sure you don't drop those negatives. And then -2. We're going to call this matrix A. The answers are going to form a second matrix, which is simply 60, -12, and -52. And we're going to call this matrix B. Pretty simple, huh? That's how you set up a matrix. Let's make sure we understand. So again, you bracket and you bracket. In the first one, it is 4, 5, -6, -3, -2, and 7, and then -1, 4, and 2. And you can have zeros in a matrix. If you have a 0 in the matrix, that is totally appropriate. So if I were missing a variable term, I can put a 0 in a matrix. My answers form B, which is 2, -15, and -13. Pretty easy, right? Let's do the last one. So you don't have to necessarily draw the brackets, but visually you have the brackets. Should be -2, 5, 3, -4, -3, -8, 6, 8, and -5. That negatives looked a little weird. And then our B is going to be -25, -39, and 14. Easy enough, right? You're like, Miss Wood, this is too easy. I got this. Okay, great. I'm glad you've got this. How do we solve these, though? Well, to solve them, we are going to do the inverse of A times B equals X. Now, I told you before that we're writing two matrix, but in the event we're actually writing 3. Well, where did the third one come from? The third one came from our variables. So if A has all of our coefficients, X actually is going to be X, Y, and Z. And it's going to be equal to B. Now, this kind of makes sense because I can do A times X is equal to B. Divide both sides by A. So X is equal to B divided by A. Now another way of writing that is A to the -1. So this can be also rewritten as A to the -1 times B. These are all equivalent statements. So I need to figure out what the inverse of A is in order to solve this. Because what this says is the inverse of A times the answers, which is B, equals the values for the variables, the X, Y, and Z, the A, B, C, whatever your variables happen to be. So we need to find the inverse of A. Well, when I was taught way back in the Stone Ages, before the creation of computers, before calculators, when we were using rocks and chisels, we had to do it by hand. Well, but the standard says with technology. Why should I ask you to do it by hand when there's technology available that will tell you how to find the inverse of A? In fact, it will walk you through the solution, doing all of the computation. I don't see the point in teaching you basic computation skills. That just gets too super confusing. Not when it says technology. So the steps for using the matrix calendar are these. We're going to enter the matrix in A. Then we're going to click the button inverse of A, because remember I said I had to find the inverse of A. And then we're going to multiply that. Now click the button to A. What it's basically going to do is overwrite the numbers we have with the inverse button. And you'll see that when we go through this. Then enter the answers in B, and then you click the button AB. So if you don't have this written down, you should write this down next. This is the steps that we're going to follow in order to solve these. So let's try solving the first one. So remember, our A on this is -5, 1, -4, 2, 4, 3, and 6, -3, -2. Our B is 60, -12, -52. So let's go to our matrix calculator. So first thing is we have to enter in A. So we're going to type in -5, 1, -4, 2, 4, 3, 6, -3, -2. So step 1 was to enter the matrix into A. This is our matrix for A. It was a 3 by 3, and we've typed it in. Now we have to click the button inverse of A. So here's the inverse A button, and you can see all sorts of numbers show up down here. Excuse me. I don't want you to start typing. You just hit the button 2A, and you'll see all of these numbers are suddenly going to change. And all they've done is copied the information that's here in the box and put it in here for A. So remember, it's the inverse of A, because this is now, in this A box, is now the inverse of A, times B. And our B for this one is 60, -12, 52. So if you notice, it's not going to be a 3 by 1 or 3 by 3, it's going to be a 3 by 1. So you need to make sure that your rows are correct. Then you need to type in 60, -12, -52. Then there's this button here that says AB. These are our values for X, Y, and Z. So the one line in which, or the one plane in which each one of these equations are equal to each other. All three of these equations are equal to one another at the location -8, 4, -4. So X is -8, Y is 4, Z is -4. Let's see this in action a second time. Okay, so on this one, as a reminder, we have 4, 5, -6, -3, -2, 7, -1, 4, 2. That is our A value. Our B matrix is a 3 by 1, which is 2, -15, -3. You go to the calculator, if you hit refresh, it'll go all the way back to 0/0. Step 1 is to enter the matrix in A. So 4, 5, -6, -3, -2, 7. And just so you know, I'm not using my cursor, I'm hitting the tab key. It jumps to the next box. -1, tab, 4, tab, 2. So step 1 is enter the matrix in A. Step 2 is to click on the inverse of A. And it does all of the math necessary in order to find what is the inverse of each one of these. Then we need to copy paste this into the previous box. So we're going to put it to A, and it's going to write over the top of it. Excuse me. And then we're going to type in B, and as a reminder, it's not a 3 by 3, it's a 3 by 1, which is 2, -15, -13. And then we go down to the bottom where it says A times B, because this is technically the inverse of A times B will give us the solutions. This is this is X, Y, and Z. So -3, -2, and -4. Last example. So, A is going to be -2, 5, 3, -4, -3, -8, 6, 8, -5. B is going to be -25, -39, and 14. It's already blank. Step 1 is to enter the matrix into A. So -2 tab, 5 tab, 3 tab, -4 tab, -3 tab, -8 tab, 6 tab, 8 tab, -5. Step 2 is to click the inverse of A button. It does all the crazy math for you. Then you need to copy paste this into A. Remember, B is not a 3 by 3, it is a 3 by 1. And its answers are -25, -39, and 14. And then you simply multiply. This is the inverse of A times B. So my X is 8, my Y is -3, and my Z is 2. So for the following quiz, I need you to make sure that you're able to set up the matrices, correctly. So you'll be given a couple of systems of equations, and you'll need to set them up. And then you'll need to solve them using the matrix calculator. I'm not asking you to solve anything anyway other than type the matrix into A, click inverse A, click the 2A, and then put the answers in B and hit the AB button. I'm not asking you to do any computation. One thing I want to make note of. Let's say that there's no 8 here. Because it's in the y position, you have to remember that the 0 that would go there would go in the center for y. So it would be 6, 0, negative 5. If I'm missing my 6, or sorry, let's say I'm missing the negative 4, it would be 0, negative 3, negative 8. And let's say I were missing the z, this would be negative 2, 5, and 0. So please pay attention to where the zeros go, because, oh, hint, hint, perhaps there will be zeros in the matrix you must set up. You should be able to solve these matrices very simply using the scientific or the matrix calculator provided and the steps.